Hey, geometry honors, I'm sorry to do this to you after your test, but I'm not that sorry. I'm just a little sorry. So we're done with chapter 3. Instead of going to chapter 4, we're going up to chapter 9. Chapter 9 is going to help us a little bit with chapter 4. We'll talk more about the geometry side of chapter 9 later. Let's talk about the algebra remediation. Today is going to be part 1 of radical remediation. We're going to do part 2 much later, like around chapter 8. First of all, these items, are these true? If I have the square root of 36 and the square root of 4 being added, can I shove them together in one radical? Can I do that with subtraction, multiplication, and division? Well, let's do these according to order of operations. Square root of 36, 6. Square root of 4, 2. 6 plus 2, this side is 8. But if I do this side, I get the square root of 40. Is 8 equal to the square root of 40? No. This is not true. We cannot do this. We cannot add separate radicals and shove them together. That means we can't go in reverse. We can't take a sum of radicals and break them apart. What about subtraction? 6 minus 2. That's 4. 36 minus 4 is 32. Is the square root of 32 equal to 4? And the answer is no. We cannot subtract radicals this way. If you are subtracting two radicals, they do not just shove together into one. That is not allowed. And if you have a subtraction under a radical, you can't split them apart. Let's go to multiplication and division. Square root of 36 is 6. Square root of 4 is 2. 6 times 2 is 12. 36 times 4, I just calculated that to be 144. Square root of 144 is also 12. These do match. Although this doesn't technically prove anything, this is just illustrating that yes, you can. You can have a separate multiplication and cram it together, or you can have multiplication and split it. Division, we have 9 over, I'm sorry, that's not 9, big silly, that's 6 over 2, and that equals 3. 36 over 4 is 9, that also equals 3. So division can do it as well. So in summary, and you may want to write this part down if you haven't written anything else down, we cannot add radicals like this. We cannot subtract radicals like this, but we can multiply and divide. Okay, so these are the yeses and these are the no's, so please make a note of that. All right, now let's talk about how we can apply this. All right, so we're gonna do just a couple of problems. I'm not gonna make this video super long because you don't want it and I don't want it. First, let's just do a quick refresher on simplifying radicals that are just maybe a tad more complicated. Okay, we know that we have to try to simplify the square root of 68. This negative 4 is multiplied with it, so we're gonna deal with this first. Now I know most people don't know what goes into 68, but it is even, so I'm gonna try 4, and it turns out it's 4 times 17, so that was a good breakdown. So if I give you numbers you can't do, just play with them. So that 4 will multiply with that 2, and we will get negative 8 over 17. All right, now let's get to actually applying these properties, adding, subtracting, multiplying, and dividing. Number 2, what if I actually want to distribute? Okay, now this is a single entity, and this is a single entity, and this is a single entity, or term. So just like any distribution, we're going to distribute and distribute. So 3 root 2 times 4 root 3. Now we're not gonna like FOIL these pieces. We're gonna literally just multiply what we can. 3 times 4 is 12, and 2 times 3 under the radical is 6 under the radical. Under the radicals, we can combine. So that's 12 root 6, and then we have 3 times 2 is 6, and 2 times 6 is 12. Now I can simplify the root 12 into 2, so that ends up being 12 root 3. We cannot simplify these. We cannot put them together because according to the add subtract rule, we have no right to do so. Okay, so there's our final answer. Now for number 3, we have root 50, and we're gonna add that to root 18. Now this one seems like a no-brainer. We can't call that root 68. We already established that. So this seems like we can't do anything. But what I recommend you do is still try to simplify the radicals. So this simplifies into 5 root 2 when you break it down. This simplifies to 3 root 2 when you break it down. Now these radicals actually match. I want you to think of this as if this was like algebra. What if root 2 is x? If you had 5x plus 3x, aren't you allowed to call that 8x? Isn't that like terms? So you can add these if they're like terms. This is 8, not root 4, but root 2. Just like down here, 5 somethings plus 3 somethings is 8 somethings. 5 root 2 plus 3 root 2 is 8 root 2. So adding radicals is strict. You can't do it if they don't match, but you can if they're like terms. You've got to treat them like terms. All right, I just have a few more for you. All right, number 4, let's do some foiling. Ugh. This one is not pleasant, but that's okay. So we're going to FOIL this. All right, we have 2 terms times 2 terms. So this term has to multiply with this, has to multiply with this has to multiply with this has to multiply with this. We have to FOIL it. So first I'm going to do these 2. Now remember from the last one, the 2 and the 4 multiply to be 8 because we are multiplying. We can do this. And root 3, root 2, root 6. That is the first. Now this term of 2 root 3 has to multiply with 3. So 2 times 3 is 6, and the root 3 doesn't have a partner. Now we have to make sure these 2 multiply. So we have negative 5 times 4, which is negative 20, root 2 times root 2. Well, that's root 4. We can also call that 2, and it's multiplication. And now we have to multiply these. Non-radicals, 5 and 3 become 15, but there is a root 2 on it. So these become 15 root 2 with a negative. I see no simplify, any radicals that can simplify well. This becomes 40. I think we're done. Now you might look at this problem and say, well, wait a minute, 6 can break down into 3 and 2. Can we somehow combine like terms here because there's 3's and 2's? Not really. These aren't like terms. This is like saying 8xy, this is saying 6x, and this is saying 15y. They're not like terms. So breaking this down into non-perfect squares is a waste of time. This is as far as we can go. Okay, I'd like to do 2 more. Okay, so we have a 2-term situation here. We can't call that root 3 because these are not like radicals. We can't subtract. Can't simplify them, so we have to square them. Now you want to be careful. You can't just distribute an exponent. You actually have to write this twice and FOIL it. That's the only way to handle that. Root 6 times root 6. Again, you can call that root 36, but I'd rather you just think square root of blah times square root of blah is blah. I'm going to multiply these 2 together. It's a positive times a negative, so it's a negative, and then 6 and 3 can multiply because we're multiplying now. That's root 18. This is also root 18 and negative. And then this, negative times negative, is a positive. And root blah times root blah is blah. 6 plus 3 is 9. Negative root 18, negative root 18 is negative 2 root 18s, because those are like terms. And then don't you dare call that 7. That violates the order of operations. But we can simplify root 18. 2 times 3. 9 minus 6 root 2. Don't you dare call that 3. That violates the order of operations. This is a term. This is a term. They are not like terms. We're done. Final problem. You're actually going to see questions like this a lot later on in the course. Now, if we compare to number 5, it's kind of identical. We have some crud that needs to be squared. Here we wrote it twice and FOILed it, and we can certainly do that here. Write it twice and FOIL it. Actually, let me restate that. We can write it twice. We cannot FOIL it. Foiling is when you have 2 separate terms with a plus or minus between. This is pure multiplication. So you can actually drop the parentheses and put little dots if you want between them. There's no foiling here. This is all multiplication. So the negative 4 multiplied to be 16. Root blah times root blah is blah. And then 16 times 7, which most of you don't know off the top of your head, is 112. So we have, I think that's our final answer, right? 112. All right, so I ask that you now try the homework that I posted. Thank you.